So we want to talk about API security. A lot of what you've heard today has been protocol, right? Very, very sort of tight, highly technical information. So the question is, how do you take that stuff and put it into a bigger picture? And, you know, first of all, there are a lot of great things about what you've heard today, right? That maybe haven't been explicitly talked about, but they're pretty great, right? First of all, you don't have to authenticate people, right? As the developer in the room or the architect of the API service, authenticating the user is not your problem. You get to make a redirect to a separate service, and that separate service could be voodoo magic that, you know, voodoo magic is a service that could authenticate those users. You don't care, all you get back is a token, and you can then use that token at APIs. So that's pretty great, right? It insulates you from a lot of volatility in your organizations, and it lets those people focus on those things and make them stronger and stronger over time without the change management nightmare that is trying to get, you know, change every single API every single time when you're trying to be agile. So that's number one. The second thing is, you know, if you're a developer, then you don't even really need to worry about the client side, right? You're going to be given a client credential, and you're just going to use it. You're going to use that credential to request an access token, and once you do, you can forget that client credential too. You just cache your access token and use it, cache it and use it. When it dies, you start the whole process over again. So really, it becomes very simple, very repeatable, and the stuff that isn't simple and repeatable is not your problem. Or is it? So maybe you have to work with your IT department or your identity professionals to get this stuff in. And if that's the case, then what I'm hoping is we can talk about a few things that are going to help you, A, make the value proposition really obvious, and B, sort of let you speak the same language so that you actually achieve a secure solution. Because there are, as in any API operation, you can do it badly, right? It's a beautiful tool, and you can shoot yourself in the foot with it. So the goal is to give you a sense of what things work well and what things are a total disaster. So first of all, just to talk about what an identity platform is. I don't know if you can see that all the way at the back, but ultimately at the very top you have your interfaces, right? And then in the middle you have all the policy stuff that the identity people will be defining, like scopes and trust management and PKI and all that stuff. And then on the bottom you've got the services that are the kind of the volatile business-specific services, right? So authentication services, right? That's a piece that could be huge. It could be multi-factor authentication. It could be risk fraud analysis. You could be doing keyboard biometrics, all this stuff, right? So really, the interfaces that sit on top let you not care about the stuff underneath, which is great. But there's sort of three pieces that were talked about today, and I just want to group them together. So automation services is basically how do you become a client in an identity platform? How do you get a client secret and a client ID? How do you register for that? The second one is token services. So that the authorization server that Travis was talking about, that's part of token services. And there might be other token services like SAML, for example, that you might want to interact with. And then lastly, you have your identity APIs. And that's the user info endpoint that Jacob was talking about, right? So you have endpoints and you have APIs. They're all standardized. They work the same way every single time, which is why they're valuable. All right, so I want to just talk about some patterns, how some of these APIs actually work over time, within your software. Okay, so here's the first one. This is what I would call it the pure backchannel pattern. Okay, so this is your, you've got an app or a script that has no user attached, right? It's purely, perhaps it's business to business or it's a service client, right? In that case, you want to integrate API, OAuth 2.0 into your API. You don't need a lot else. You just need OAuth 2. You may want maybe one other specification called the JOT assertion flow, but let's just go through it here for a minute while I point at stuff. So first of all, if you can automate your client, right, to get not just a token, right, which is the one in the middle, but to actually register and get a client ID and client secret automatically, then you win. So you can, for example, there's a protocol that will let you wake up as a piece of software, you know, at configuration time and say, hey, I don't know what to do. What can I do? And you can go to a .well-known file at the domain, and you can say, oh, look, I can use these scopes, I can use these signing algorithms, there's all this cool stuff I can do, let's go get me set up. And it will actually automate the provisioning of a client ID and client secret, right? Now maybe that's you going to a developer portal where you put in your personal developer creds, and it spits out and says, here's your client ID, here's your secret, right? Those are the two things you need. Great. So it can be fully automated or it can be manual, highly manual, whichever you want. But the second thing is, once you have that client ID and client secret, then at boot time, when your software is actually starting, generally, then you're going to request this access token, right? You're going to make an OAuth-2 request. You're going to get an access token back. That is called usually the client credential flow. So when you look through the OAuth specifications, you're going to see that you have a set of client credentials, and you want to trade those client credentials for an access token. And then after that, this is the stuff, you know, we assume, but we don't always talk about, is you're going to call your APIs. And what you're going to do is you're going to throw, instead of throwing the username and password or the API key, whatever it is, into your basic authentication header, you're going to throw this access token in instead, right? So if you think about it, you get your client credentials here, you use them once, and then never again. Just a second. I should have seated some ringers who could stand up for me when I'm coughing. Excuse me. So from a security perspective, if you're analyzing the security of this, your credential, your secret, only goes over the wire one time, and that's when you start up, right? That's only one opportunity for an attacker to get that secret, right, and impersonate your client. The rest of the time, all you get is the access token, right? And the reason that's significant is because the access token is only scoped to do one or two very small things. So if somebody steals this access token, intercepts it on the wire, they can't impersonate you. They can only call that API with the scope that they asked for, right? That's why it's so great. They can't request different scopes. They can't do anything except that one tightly bound little piece, right? So if you think about it, this is where the bulk of your operations exist, is at runtime, right? And whereas the security risk is all over here in the boot and config time. So that's one of the biggest advantages of OAuth 2.0. I think I've covered all this, but I wanted it written down so you could look at it later. Let's see. I will say that, you know, if you think of what an API key is, it is a symmetric secret. It has to be saved and known on both sides in order to be matched when you authenticate. You may want to use private keys and use cryptography instead, right? And the advantage to that is that there is hygiene around using private keys, right? So you can put it in an HSM or some other security mechanism. So that's something to think about too. In this case, you don't need any extra scopes. There's nothing but OAuth 2 that requires scopes. So here are the risks. I think I did both of these. The only one is the dynamic registration. I mean, it sounds like it's a lot of work, but here's the great thing about dynamic registration is your developers can't hard code something in and say themselves, I'll deal with it later. And that's a major improvement. What we're seeing right now from a security perspective is hackers are scouring open source code repositories right now, looking for hard-coded credentials. And they use those hard-coded credentials to then access and attack your employers, right? So pretty well the worst thing you can do right now is hard code a credential, even for 10 minutes, right? All it takes is one code check-in that you weren't thinking about it, and those credentials are somewhere where someone can find them. So anything that can be done, as soon as you start rotating it, what you're doing is you're forcing rigor, right? You're forcing them to go get a new one and use it, and then go get a new one and use it, and they lose their dependency on the idea that they can just save it, and they'll make it more secure at some other time. Okay, pattern 2. Travis, you're watching time, right? Okay, good. Pattern 2 is the same idea with users added. So now, whereas before it was really just an HTTP fetch like any RESTful call, excuse me, now you have to have a way to interact with the user. So as soon as you have a user in this, there's really only two options. You're going to prompt the user through your software, or you're going to put up a browser and redirect the user. Now, OAuth will allow you to do both. However, prompting the user directly is not a best practice, and we do not recommend it. And the reason we do not recommend it is it doesn't allow you to do anything except username and password with your users. A lot of companies now are trying to do multi-factor authentication because password reuse is so bad right now that attackers are simply hacking small websites, not big ones. They're hacking the small websites, taking the email and password couples that come from that and trying them at major organizations. Excuse me. I tried to make my entire point. So because password reuse is so bad, forcing your apps into a paradigm that can only ever ask for a password is a terrible idea, and it's highly, highly discouraged. So the difference between that, so what I'm really saying is you need to pop a browser. And here's where you need to do it. So you need to do it during operation time. If you look at this diagram, you've got your discover and register step, right? Whatever that is to get your client credentials set up. And then at the time of operation, instead of having your access token already at the time you operate, you wait till your user comes along. When the user comes along, you make your request in real time with the user present in the browser, right? You pop the browser, you redirect off, voodoo magic happens, right? And when you come back, you have an access token. And guess what? It looks just like the access token that you get if there's no user around. So from your code's perspective, there's no difference between a delegated user flow and a back-end user flow. They're identical to each other, right? You open the browser, you make your request. I guess the difference is there's a browser involved. But you open the browser, you make the request, you get back your access token, and then you proceed to use the access token, right? Exactly the same. Your API doesn't know the difference. It doesn't know or care that it's a user delegated token instead of a regular token. It just knows that it has the right scopes, and so it will give the data to your client. All right, so same idea. The difference is the transport layer changes, right? So now you're doing essentially a bounce on the front channel in the browser, and then if you're doing a bounce in the back channel in the browser. So that's what's called code flow. And the reason that's important is because, as we all know, the browser is not the most secure place in the world. And you really want to keep these access tokens out of the hands of man in the middle or another attacker. So what you do is you make the request over the browser. You get back an authorization code, which is a one-time use code with no data. It's a pass-by reference token, as Travis mentioned. You use that little thing to then make an authenticated call with your client credentials to a RESTful endpoint to fetch your actual identity data. So that's the security beauty of it, is you use the browser, but you only use it long enough to get a very quick hot potato, if that makes any sense, and then you pass that to your identity service on the back channel and get your real information about the user. All right, let's see. So risks and mitigations. No cached user credentials. This is huge, right? This alone is the benefit, is the primary massive benefit of OAuth 2.0. The alternative is caching your users' primary credentials on a phone or in a piece of software where if it's stolen, not only do you have access to that one single app, you can impersonate that user in everything they do in their daily life. Everything that credential is good for, somebody can now be that user. So to take away the risk of that data being found at rest in your application, of the data being stolen in transit, all of that risk goes away. The other thing it does, for those of you who are actually operating the APIs rather than the clients, is the API no longer has to have the capability to validate user credentials. So if you think of, maybe you have 50 APIs in your organization. Every single one of them has a high assurance credential to be able to validate passwords. Every single one of them is a harvest point for user credentials, right? If you're rogue, you could just sit there and watch those usernames and passwords come in and save them for later, right? So by using something like OAuth, the API loses that high credential, don't need the credential to validate anymore. All they need to do is validate tokens, not user credentials. So it's a huge, huge advantage from a security perspective. There is one problem about the model that I just showed. There's no identity in the model that I just showed, right? You ask for a token, right? Magic happens, identity happens away from you, you get a token back. But you only get a token. You don't get information about the user's name, you don't get information about who the token was originally for or what the token was originally for. And so there's an attack in this model. I'll just go back to the picture so you can see. So there's an attack in this model where a bad actor, right, convinces, let's say you have a small app in your organization that does something really benign, and there's a bad actor. Well, they can convince the user to consent and get a token, and then they can take their token and put it into your client, right, insert it in, and all of a sudden you've got an access token that works. Pardon me. The only thing that protects you in this case from what they call token substitution acts is how tightly you've scoped the token. So if you have one token, if you have a token and it's basically got one scope and that scope is everything, then you can trade access tokens between your different pieces of software, right? You can interchange them. And nobody wants that because then you can do escalation of privileges, right? You want the tokens that come down for this particular client to be good only for the APIs that are affiliated to that client. So this is useful, but almost always you need some kind of identity in it. Which brings me to the last one. This is the OpenID Connect flow. So what you can see is it's identical, again, to the original OAuth 2 flow, right? You still have to get your client credentials somehow. You still have to make a request in the browser. You still have to fetch your tokens, right, using an authenticated client backend call. The difference is this here. You get 2 tokens instead of 1. You get an access token and you get something called an ID token. And again, the API doesn't care. API still gets its access token. It's happy under all circumstances. This is what an ID token looks like. If you'll notice, it looks a lot like the data that came back from the user info endpoint, right? It's all JSON. The difference is this has user information, but it also has information about the actual authentication event that the user underwent. So now I know that the access token that I received, right, was issued by a specific domain. I can see it. I can tell here, expiry and issued at, I can tell when it was issued, right? So I know if it's a weeks old ticket or if it's a brand new ticket. I know how long it's been since the user last authenticated. So maybe if you think about Facebook, how often do you authenticate to Facebook? Maybe once a year, right? So if you're trying to do something highly secure, a high authentication time might be a really bad thing, right? So this is a way for the server to tell you how long it's been since the user authenticated in case you decide you have to make an authorization decision, right? To either go back to the server and say this is no good, I need a higher level of assurance or something like that. And then this is optional, believe it or not. It's a hash of the actual access token. So I can prevent token substitution attacks, right, by checking the access token I got is the same, can be hashed to the same value that's in this token. This whole thing can be signed, right, and encrypted. So it can have, it can be trusted in most circumstances. And then the last thing is the audience, right? So that audience means I can tell if this whole package was intended for somebody else, right? I know that the server issued this thing to me and only to me. And if something shows up for someone else, I can get rid of it. And you can't do that in OAuth 2.0. Sorry, pause for coughing break. So, I think I've covered all of this. Oh yes, the one last, most important thing is, if you think of OAuth 2.0, your token can look like anything, right? You can use any request method to get it. It's wonderful, it's free, and it's open, but it's not interoperable. You can't, expect to write code for one OAuth framework or one OAuth architecture and have it work for another. They don't work that way, right? There's too much that's left open. What OpenID Connect does is it standardizes some of the most important pieces. So you know what the ID token looks like. You know what kind of flows are supported. You know scopes. So in this case, you have a scope called OpenID, right? So you know that if you see that scope, it's a reserved scope. What this means is now you can apply it as a generic solution to any architecture. And what that means is now you can find libraries that'll do it for you, right? And you can take any library and use it against any platform, and they're going to work. And most importantly, there's a huge conformance testing effort going on right now in the OpenID Foundation. So not only are the libraries there, the libraries have been proven to work against the known providers, right? You don't have to guess that they're maintained or not. And you can go run the tests yourself. So instead of spending a whole lot of money on something that you think is secure, but maybe somebody's made a shortcut, you can actually go and see that it's secure. And you can essentially talk to your regulators, talk to your compliance people, and say, if we're using this library and we can prove that it passes the test, then these 5 things are checked off my checklist for compliance. So, OpenIDNet Certification, if you want to look at it. Right now there are tests for the provider, which is called the OP, but there are tests for the clients too that are coming up in the next 3 or 4 months. Take a look at them, they're free. The certification is not free. The tests anyone can run, and you can either run it online or you can go to GitHub and get the actual tests themselves and pull them down and run them locally so that you don't have to leak any information about your services. All right, so how close am I? Perfect. All right, so obviously this is a fairly complex thing, right? There's lots of rules to the specifications, but they're here for a reason. And so there's a few things I just want to make sure you walk away with. And I'm going to start at the bottom. Don't go building an authentication API, right? Don't do it. Just don't. It's hard work. There are a lot of gotchas. A lot of people have worked really hard to create these standards. And I'm not saying don't build yourself. If you want to build yourself, build it. But don't make it up in your head yourself, right? Go to the standards, read the standards, and make your homegrown solution according to those standards, because they really have thought about the dangers of all these redirects and all these REST API fetches and all this stuff, right? They've got fancy things like nonces and state, and they're looking at CSRF attacks and token substitution attacks. So whatever you do, if you want to build it, build it. Just build it and use the guidance that's there. Other than that, there's some little things that you shouldn't do. So what you didn't see here is me talk about a flow called the implicit flow. Okay, the implicit flow is a flow where your client only works on the front channel. It only uses the browser. And it doesn't have a client secret. It just makes a request and gets a token back. It's the easiest thing ever, right? And it sounds wonderful, but the risks involved are extremely heavy, right? This is what Facebook uses, by the way. And they do it without SSL, right? And you wonder why people hack it. There are reasons for implicit flow, okay? The reason why implicit flow was invented was that There are some mobile clients or JavaScript widgets that are incapable of keeping a secret. And so the architects thought, you know, the only thing worse than having a secret is having a secret that's so easy to steal that it might as well not exist. So if you need to use implicit flow, you need to research it. You need to talk to somebody like Travis who can tell you where the problems are. You need to really understand it. Redirect URI, so when you make your request, you have to specify a callback URL for how the service can get back to you. If you have a wildcard in it, if you do anything other than give it an explicit URL, then you will be hacked, right? There are examples already of that happening. It allows for rogue insiders to mess with that URI and redirect your tokens to somebody else's server. So don't do it. And last of all, there is a document that outlines all this. This is the beauty of it, right? You don't have to think it all up. You just have to read. And so RFC 6819 will show you where the problems are and what you can do to mitigate them, right? So you're not alone. This isn't a case where you have to sort of swim out and you know, battle the world. There are people who will battle it for you and with you. So I will leave you at that and hope you walked away with something good. Thanks.